minutes please bear with me. So, basically a mechanical engineer, and he is presently is heading Department of Information Management and Coordination, and he has his area of specialization is manufacturing technology and computers in manufacturing, and he has rich experience of around 30 years in industry as well as academic institution. So he'll be just joining us few minutes, and then we'll be starting the session. And after that, we will have a session. The second session will be by Dr. Amod Kumar, who is Chief in Central Scientific Industrial Organization under CSIR. He will be telling us about the biomedical instrumentation, the research areas in the biomedical instrumentation. So we will, our first session will be taken up by Professor Pabla. So he's just joining us. In the meanwhile, I just want to ask in Madhav University, Madam Madhav University का देखें कितने सरकारी.
We are all electrical engineers.
नहीं सर मिक्स कर. आपको मुझे बाहर दे उतना ही मिला.
No.
आप कुछ बता रहे थे.
कोई प्रॉब्लम. आधा घंटा. Very good morning to all the participants from the centers. Okay.
I have briefly introduced him. I'll just reiterate with few words. He is Professor B.S. Pabla. He is at present heading Information Cell at our institute, and he has been head of the Mechanical Engineering Department. His areas of specialization are manufacturing technology, computers in manufacturing. He has got a rich experience of around 30 years as in the industry, and also he has been a principal of Standard College of Engineering and Technology at Chandigarh, and he has written several papers in esteemed journals as well as presented papers in the esteemed conferences across the world. So I request him to kindly highlight the research areas in the field of mechanical engineering.
How many centers are there?
9 centers.
Okay. Very good morning once again. Due to some technical problem, we are starting late, but we will end at that time. Topic which I have been given is emerging research areas in mechanical engineering, basically. But what I talk is probably true for all areas of engineering. First of all, I need to ask a question. Why do we need engineers in society? Or what engineers do in society? Engineers, irrespective of the discipline, mechanical, civil, electrical, electronics, they are basically supposed to for human convenience. Focus on solving existing problems, give new products which are not there, give sustainable solutions, and socially acceptable solutions. Your solution may be very good. If it is not accepted socially, that is going to fail. So if you look around, everything you are using now in the classroom, in your offices, in your houses, it is all engineering. This chair you are sitting on is also engineering creation. Computer I am using is engineering creation. Projector you have is engineering creation. And it has made my life as a teacher easier for me to communicate with. Now coming back to research areas. The most important aspect in research is now that there is collaborative. There is nothing called research mechanical engineering, research electrical engineering. Mechanics don't have information about materials, about computer engineering, about electronics. Probably I cannot do any development. I may be able to do some theoretical research, but when it comes to development of the product, it is very difficult. So research is now multidisciplinary. Now, if I want that type of research, that means, or I want my students to do that type of research, I need to develop similar type of aptitude capabilities in the students. I'll give you an example. We in mechanical engineering, we have a surface roughness tester. Now, before that, research is not only disciplinary in engineering areas. Research is now multidisciplinary, including all sciences, medical, arts, all areas. Now, coming back to that surface roughness tester, we were very sure that it is medical equipment and we are the experts and we are only the users for this. About 2 years back, a student from dental college came to me. He said, "Sir, do you have surface roughness tester?" I said, "Yeah, I have." "Sir, I want to use it." I said, "Why?" "Sir, I want to check the surface roughness of a tooth, which I am doing research." So where mechanical engineering in this? Then they want to check the hardness of the tooth, which we have been doing. They want to check the profile of the tooth with the help of a scanner. There is a lot of medical engineering now. Engineering in medicine, lot of things, lot of mechanization, lot of robots are being used into the even operating people, patients. Even your heart transplant, people are using robots. So if you see, I went to USA in December. There was a conference by Autodesk. I didn't find any mechanical engineering research there. It was all on medical sciences. All on medical sciences. I saw a person who has lost both the legs, and he had artificial legs, and he was walking, running, jumping. So I was surprised. He showed me showed us the pictures when he was lying on bed. At the same time, he was running in front of us. Now he says, "I am running a company on bionics." He says, "I am doing research on these areas and I'm providing facilities to the, doing research on providing facilities to the patients like him." And he says, "I am better off than a person with natural legs. I can increase the length of my legs. I can decrease the length of my legs in a lighter way." And he said, "Depending upon the girl in front of me, I can reduce my size. I can have the same size." So there is a lot of work to be done. Whereas if you go to my first slide, how to make the life of the common people or peoples or person with disabilities also, how to make it simpler, how to make it easier for them. A lot of work is going on. Maybe we will come to it in India. It will take little time to come to India, but US and all advanced countries, they are doing a lot of work in this. As far as few areas I could list out. Now this is not the end. There are many more areas. The areas which I feel where research is required is materials. You see, we are always trying to reduce the weight to volume ratio or weight to strength ratio. That means we want lighter materials. At the same time, those materials should be very strong. Now the materials which we already have, there are strong materials, there are lighter materials, but the strong materials are not lighter and light materials are not strong. So people have tried to blend these properties. There are cases where you not need a strong material which is strong throughout. Maybe you want the material to be strong at the surface itself, right? That is a cutting tool. Now cutting tool cuts at the surface only. Only top surface layer is used. So why should we have a cutting tool which is made of a very high cost material, very strong material, which is throughout the cutting tool. So what we did in our institute, we did plating on the cutting tools, tool bits. So the outer surface was made strong, wear resistance, and normal material. We did on MS only, MS tips, mild steel material. The outer surface was coated, and we could increase the life of the tool by 35 to 40%. There are materials which are being used in biomedical. Let's say knee replacement, hip replacement, even in your heart operations, stents and all. We need different properties of materials. Let's say in knee replacement, titanium is being used. Some problems with titanium. Knee material, where there can be growth, there can be natural joints. Lot of work being done. So material is one area. Properties, special properties, lighter weight, smaller size. That is one area where a lot of people are working. Energy is another area. We are short of energy. There is a need to explore alternate sources of energy. You see, we are using solar energy. We have a solar power plant here. We had already kilowatt solar plant here. The cost is very high. That 50 kilowatt solar plant, Professor Poonam is only looking after this. That costs us 47 lakhs rupees. That means almost 1 lakh per kilowatt. That is a high cost. And we went with a power plant with batteries. If you add batteries, another 40% will go. So that means 1.4 lakhs per kilowatt, very high cost, and there is a lot of cost associated with the maintenance of batteries and replacement of batteries. We need to explore other ways of energy. Let's say solar energy, wind energy, tidal energy, and maybe small hydel plants also. The running cost of hydel plant is very low because you are not consuming anything. We need to work on these areas. Food preservation, very important area, because whatever we are doing is for food. And at the same time, a lot of food is being wasted. Either due to negligence or due to people not being aware, or due to wrong estimates. Once the food has been cooked, it has to be preserved so that it can be reused. Can we do something in this? Automation. Automation is another area that we want to automate everything. Automation means that we want to minimize the human interference in the process. We want to minimize the human interference in the process. We want that once you start, the process should go on without any human interference. Now, I have been talking on this area, let's say CNC machines. People question me that automation brings unemployment. Maybe at some places, but normally what I say is that when automation comes, it brings different types of jobs. It creates different types of jobs. Manual labor jobs to some high skill jobs are created. So automation is where all disciplines will be used: mechanical, electrical, electronics, computers. If we can automate, we can save human labor, and we can provide better facilities, better work environment to the working population. Very important area is miniaturization, that you make it smaller. Make it smaller. We have been seeing around us also. Take the case of a take the case of a mobile phone. It started with a very big size. Now there are 2-inch, 3-inch mobile phones also. Of course, 4-5 inches we are using, but that people have made it possible to bring the mobile phone into a watch also. It is a part of your watch. So make things smaller. That will depend on the technology available and on the research and development work which is going on. Optimization. Now optimization doesn't belong to any discipline. Optimization everybody does. Mechanical people will also do, electrical, electronics, computer people will also do, all other disciplines will also do, and non-engineers will also do optimization. So optimization is one area which every engineer should work on, and he can use in his research work. We at NITTR, we did a lot of experimentation to optimize the cutting parameters in machining of materials. And what you do is, we have been able to attain better cutting tool life, better working parameters, and better surface properties of the materials being cut. Similarly, we have been doing, let's say, simplest problem is a traveling salesman problem. Placing of components in a chip. When you are making an IC, how to make the IC with best placement of components within the IC. All starting from very simple problems to very high level problems, we can use, and we have to use optimization, because manually it may not be possible. When there are 1 or 2 parameters used in any process, you may be able to do it on manually. But when the number of parameters and number of levels means the values they can have, all the parameters increases, it is not possible to do it manually. So you need computers. There are many computer-based methods where you have to just give your problem. You should be able to define the problem. That is all. After that, the computer takes care and it gives you the best results in the given situation. Some of the other areas which I have been discussing. Bionics, I said I met a person, I saw a person, I didn't meet him, he gave a presentation that he has lost, he is working on bionics. The same person which I said, he has lost both his legs and now he runs on artificial legs. Brain computer interface. That means you interface your computer with the brain. and you put some sensors which will read the brain of the human being, and computer will take action. The computer may further be interface to a robot which can take action. Let's say I am thinking in my mind that I want a glass of water. The computer reads my brain and it gives a command. It takes an inference from my reading, from the reading which has taken from the brain, and it instructs the robot that robot takes action and it brings a glass of water. Similarly, you see, we are normal people. We can do things. There are some handicapped people. He cannot pick up his glass of water himself. And probably there are deaf and dumb people also. He cannot speak also. So the computer will read his mind and give the instruction to the robot, which will do the desired work. It will be desired work. A lot of work being done. I was in engineering college last week. Their students had made a project based on brain-computer interface. They had a robot also which was connected to the computer. So that was the basic work the students were doing, but at the same time, we at NITR have purchased the BCI equipment also. Mechatronics is another area. Mechanical plus computer plus electrical plus electronics. Mechatronics is one such area now where we do not have any escape. We have to do it. We have to study it. We have to study mechatronics, because all the systems, starting from a washing machine to robots to CNC machines, all are mechatronic systems where it is a mixture of mechanical, electrical, electronics, computers. So mechatronics is one area where a lot of work can be done and is being done. You are transferring, redesigning the mechanical systems into computer control systems. You are adding some control functions. Heat transfer. I'll come to additive manufacturing afterwards. Heat transfer and fluid flow both are very important areas with application in all disciplines. Let's say you have a if you have seen the inside of a computer, desktop computer, the microprocessor size has come down. The power of the microprocessor has gone up. Now with these two things, the heat generated by the microprocessor is very high. Heat generated is very high. There are fans. There's one fan. There are sometimes two fans. But we have to design a system there the heat transfer from the microprocessor to the surrounding is very high. Either you have natural convection or you have some fluid flowing through it, through some small micro channels. You can design your system so that the system doesn't fail. If you see the computers, they will say, okay, working temperature is up to 47 degrees Celsius. After that, the system may fail. So you have to maintain the temperature. Now coming to the additive manufacturing. Whatever manufacturing we are doing these days till now, that is what we call it as subtractive manufacturing. Subtractive manufacturing means you start a big size raw material you should keep on removing material. You keep on subtracting material from the raw material, and when you get the final component, maybe it is 50% of the original raw material, let's say by weight or volume, or 25% or 30%. Now what we have done in that? We have wasted material, because whatever you have cut, it will not be used. So let's say 50% material you have wasted. We have consumed the energy. We have used a machine. We have used cutting tools for subtracting the material from the raw material. But that you do additive manufacturing. This is sometimes called 3D printing also. That it is like a printer. If you want to make 3D printing, that means you print one layer. On that, over that, you print another layer. So do also layer by layer manufacturing. You print the material. So what you have is, you have a 3D model, 3D CAD model of the component. Then you have a software which cuts it into small slices, small layers, and based on those layers, the final component is made. Layer by layer only. There are many technologies, different technologies. We have one that is called fused deposition modeling, FDM, where we can use ABS material. That we can add material layer by layer and we get the final shape. Additive manufacturing, what my feeling is that I was talking about additive manufacturing. So my feeling is that all this subtractive manufacturing will go out. What we will have is, we will have additive manufacturing only. The only problem now we have is that the equipment is very costly. But as it is with every technology, as the volume grows, the cost also comes down. So I am expecting that the cost of this equipment will also come down, and there will be lots of saving of the material. The properties of the components made by additive manufacturing may be another reason, and another reason for not going in for additive manufacturing at all and block, because tensile strength and all we may not be getting as we have in the other components, other processes. Now another 5 minutes. What type of research we are doing? Because we have PhD program. I'm talking about mechanical engineering only. Electrical engineering only, I know one that that is on BCI. Somebody is working, brain-computer interfacing. Civil engineering, there are a lot of people working on civil engineering materials only. Mechanical engineering, we did some work on surface modification using EDM. That means you want to produce a predefined structure on the material, on the surface of the workpiece. That means you want to have a controlled roughness. Then we are working in vibrations. Friends, what we did, we developed a accelerometer on the machine. You just have the machine and you throw some light on the glass. Depending upon the reflection, you know the vibration amplitude. Now, why do we need vibration amplitude of the machine? There is some when a machine is working, if everything is all right, there should be no vibration properly. But as something goes right, gone bad, there will be some vibrations. Now, if you have database, calibrated your equipment, depending upon the amplitude of the vibration, time response of the vibration, you can make up. You can say that, okay, because vibration has gone so much, or you can have a software which gives you that take action. So that was the ME project. We are continuing with that. We want to health monitoring system where sitting in your office, you can know which machine is likely to go wrong. Through your Wi-Fi connection, you can be connected to your computer can be connected to all the machines. We had a company which is supplying electrical motors. This is a major supplier of electrical motors. They say we want to put a sensor in our side, and in our office there will be a signal, there will be data, there will be inferences coming where we will see and telephone the owner of the machine that okay, your machine is likely to fail now. We are working on vibrations in robots. We are working on gear failures. We have worked on coating of cutting tools. Because, why I'm listing these areas? Because these are all the areas connected to manufacturing technology. We basically work in manufacturing technology. We are not working in thermal sciences and design. So we are mainly concentrating on this. So these are the few areas I want to discuss with you. So I'll stop now because you have the next session after this. We missed some of the time. Thank you very much. You are welcome, please.